Hey, so today we're going to be doing section 8.2. So last class we worked on solving problems that were written in this way. Of course, A, B, and C were numbers. We worked on solving this by doing something called completing the square. That was not necessarily the easiest method to do this. What we're going to work on today is using the quadratic formula. And so it's something most people remember, the quadratic formula. I think it's a pretty cool one. So the quadratic formula is going to give us our two solutions. The first part of the formula is you take the opposite of b. Whatever b is, you take the opposite. So negative b, negative means opposite, plus, and it's going to have both answers, plus or minus, so two separate answers there. The square root of b squared minus 4 times the a from right here times the c, that's the last number, all divided by 2a, 2 times a. So that's our quadratic formula right there. I would suggest you work on memorizing it, or at least memorizing it enough so that you can write this down on a scratch sheet of paper when you start the test. Okay? So we're going to break this lesson into two halves. First, we're just going to learn to use the quadratic formula, and then we'll do a few application problems in the second part. Alright, now I will say, to prove where this comes from, if you use what we used last time, completing the square, you can prove this. I'm not going to show that right now just for time constraints, but you could look it up in your textbook, and it has it all showed, all the steps shown of how to go from completing the square to this formula. You don't need that per se. Alright, so let's start with our first example. We're going to work on solving. So solve, and let's see, we'll solve for x. Solve for x, and we'll have 3x squared plus 16x plus 5 equals 0. Now when I do this, I want to get it equal to 0. So if there is a number over here, I want to subtract it over or add it over so that everything's equal to 0, just like if we were going to try to factor this. Now let's see, so this one is our a is always for the x squared. This number right here, 16, is our b, and positive 5 is our c. And I'll write down the formula again for us so we have it on the same screen. Opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Alright, so let's actually get to work plugging in the pieces we have. So x is going to be equal to the opposite of b. So b is positive 16, so this is going to be negative 16 plus or minus the square root of b squared, 16 squared, minus 4 times, now what's our a? Our a is 3, times the c, which happens to be 5 in this case, all divided by 2 times our a, which is 3. Okay? So it's equal to negative 16 plus or minus the square root of something divided by 6. I can do 2 times 3 in my head, but we may want to use a calculator to figure all this part out. So in our calculator, we'll see what 16 squared minus 4 times 3 times 5 is. And I get that it's 196. Okay? So what we're going to want to do is see if 100 and square root of 196 reduces any or simplifies. And I'll go ahead and tell you, I cheated a little bit this time and gave one that actually is a perfect square. If you were to use your calculator and do the square root of 196, you would see that that's going to be 14. So now I can actually, since this is a whole number, I can combine these terms and find my answer. Now, since it's two separate answers, plus and minus, I'm going to want to consider this broken into the two parts. So let me go over to the next page and do negative 16 plus 14 over 6 and negative 16 minus 14 over 6. Let's see. So x equals negative 16 plus 14 divided by 6, and x also equals negative 16 minus 14 divided by 6. So let's say negative 16 plus 14 is negative 2 over 6. And that will just be negative 1/3. That reduces. And over here, negative 16 minus 14 is negative 30 divided by 6. And that's just negative 5. So there we have x equals our two answers, negative 5 and negative 1/3. So that wasn't too bad. It wasn't too hard to use the quadratic formula. Let's try another one, taking a few steps to make this a little bit more involved this time. So like I mentioned last time, notice that this one is not equal to 0. But this shouldn't be too hard to fix because I can eliminate it on this side by subtracting 3 from both sides. And so that would just give me 2x squared minus 4x equals, minus 3 equals 0. That's kind of sloppy. So minus 3 equals 0. So let me give us the quadratic formula again. Like I said, you'll want to work on memorizing this so that there's no stress on the test. Because if you have this memorized, it'll be pretty easy to use. Alright, so this is our A. Now always pay attention to the sign that's out front of the number, because that's the one that belongs to it. So notice this time our B is negative 4, and our C is negative 3. So let's be really careful plugging this into the quadratic formula. So it says negative B, so opposite of B. If B is negative 4, the opposite of it's positive 4 this time, right? Let's see, and I'll go with negative 4 squared, negative B squared, minus 4 times our A is 2, times our C is negative 3. I'm going to put parentheses just to hold the negative sign to it. All divided by 2 times 2. So let's see what we get here. 4 plus or minus the square root of something over 2 times 2 is 4. I can handle that part. So what I'm going to want to do is use a calculator again to figure this part. So 4 squared minus 4 times 2 times a negative 3 equals 40. Alright, and I'm going to want to see if this radical simplifies and if I can simplify things more. Just a little bit of scratch work. The square root of 40, see if I can fit my scratch work over here. Square root of 40, is there a perfect square that divides evenly into 40? And the answer is yeah, it's 4. So I could write that as 4 times 10. My times, it's a little sloppy there. And so break them up into 4 and 10. So that'll be 2 square root of 10. Awesome. So let's say I got 4 plus or minus 2 square root of 10, all divided by 4. Now notice something very, very interesting here. This 4 divides evenly into both terms. 4, well not evenly, but reduces with both terms. 4 and 4 would reduce, and 4 and 2 would reduce. So if it does reduce in both terms, I want to break this fraction up to reduce it as much as possible. So each term gets its own divided by 4. Now 4 over 4, that reduces just to 1, plus or minus. 2 and the 4 reduce to 1/2, or 1 over 2. So there, that's as simplified as we can go. So if, look right here, if the denominator, the bottom, does reduce with both terms, we're going to ask that you reduce it with both terms like I have here. Okay? Let's try 1 or 2 more examples and then we'll end part 1. Let's see, how about this one? X squared plus 7x plus 4 equals 0. I won't give you the formula this time, we'll jump right into using it. So now there's no number out front for our A, but what's understood to be there is a 1, right? and our b is 7, positive 7. I don't know why I wrote a 7 instead of a b. And our c is positive 4. Okay, so let's see, the formula says to take the opposite of b, so negative 7 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, or 2 times 1. So I got negative 7 plus or minus the square root of, I'll do this part in my calculator, over 2 times 1. I can do that part without a calculator. So let's see, 7 squared minus 4 times 1 times 4, and that's going to give us 33. Alright, so we need to check to see if this reduces, but after thinking about it, there are no perfect squares that divide into this. 2 does not reduce with either term, so we are done. It's a quick, simple one that can't reduce anymore. Alright, I got one more example I want to do with you before I end part 1 of this video lesson. So let's look at an example that looks like this. 10y squared plus 10y plus 3 equals 0. So plugging this into the quadratic formula, we're going to go with opposite of b, so negative 10, plus or minus the square root of b squared, so 100 squared, minus 4 times a times c, which is 3, all divided by 2 times a. So I'm going to have negative 10 plus or minus something, the square root of something, all over 20. So once again, we'll use our calculator to do, whoops, I said 100 squared. I meant 10 squared, which is 100. 10 squared minus 4 times 10 times 3. What we're going to get is negative 20 right here, which is interesting, taking the square root of a negative. That's something that we did just last test. We worked on this. So let's see if we can simplify the square root of negative 20. Well, remember, I can always break things up by multiplication and call this 20 times negative 1. And then, is there a perfect square that divides evenly into 20? And the answer is yeah, it's 4. So square root of 4 times 5 times negative 1. And the rule tells me that all of these pieces can get their own square root, their own radical, because the operation between them is multiplication. And I happen to know the square root of 4. That's just 2. The square root of 5 doesn't simplify any. And the square root of negative 1 is just I. It's a complex number. Okay, so I can simplify this square root of 20 down into 2 square root of 5i. So let's do that. So I have negative 10 plus or minus 2 square root of 5i, all divided by 20. Okay, now look, 20 can reduce with 10, and 20 can reduce with 2, so I'm going to want to break this into 2 separate fractions and simplify it. So these fractions are going to reduce. Negative 10 over 20, that's just going to be negative 1/2, plus or minus, and the 2 over the 20, that's just 1 over 10. So I don't need to show the 1 on top because there's already something up top. So 1 over 10. So there we go. And that's our solution. Nothing else can simplify any further. Alright, so be sure to watch part 2 where we'll do some application problems.